Hello everyone and welcome back to the lecture series of CAF 3 Data Systems and Risk. In this video we are going to cover chapter 3 Introduction to Data Analytics. This chapter is one of the most exciting parts of our course because it lays the foundation for understanding how organizations and individuals use data to make smarter decisions. We will begin by looking at the data analytics cycle, which shows us the step-by-step process of turning raw data into meaningful insights. Then we will move into the stages of data analytics to see how different levels of analysis answer different kinds of questions. From where we will explore the applications of data analytics in real life, from businesses and healthcare to sports, government, and even in our everyday routines. Finally, we will end with the implications of data analytics, both the positive impacts like better decision making and innovation, and the challenges like privacy concerns and ethical issues. So, by the end of this lecture, you will have a complete picture of how data analytics works, where it is applied, and why it matters in today's world. Let's get started. The data analytics cycle. Now, before we dive into the technical details, let me ask you a simple question. Have you ever tried cooking a dish for the first time? You start by deciding what you want to cook. Then you go out and collect the ingredients. You prepare them. At the end, finally, you serve. That's a cycle. Data analytics works in a very similar way. You cannot just jump into the middle. You need to follow a logical sequence of steps, from asking the right questions to gathering the right data, then to prepare it and analyze it, and finally using it for decisions. And just like cooking, this cycle is repeated again and again. So, by the end of this lecture, you will be able to walk through each stage of the data analytics cycle, understand why it matters, and recognize how it is applied in real world scenarios. Every journey begins with a destination in mind. In analytics, this destination is your problem statement or your objective. Without clarity, your analysis is like a ship without a compass. For example, a retail store manager does not just say, "Analyze my sales data." That's too vague. Instead, they might ask you which products sell the most in winter or which region is underperforming compared to others. Notice how specific these questions are. Here is an example. Imagine you open Google Maps. The app only works if you tell it where you want to go. If you don't enter a destination, the map is useless. Similarly, in analytics, you must clearly define what you want to achieve. Think about your own field of study or work. If you were asked to analyze data, what is the first question you would ask before diving in? Data collection. Once the problem is defined, the next step is to collect data. This data can come from internal sources like sales records, employee data, or customer databases, or from external sources such as social media, government statistics, or market research reports. We also need to remember the three types of data: structured data, like tables of sales numbers; unstructured data, like customer reviews or social media posts; and semi-structured data, such as JSON or XML files. Let me share a story here. Imagine a hospital trying to understand patient recovery times. Internal data might include medical records, lab test results, and doctor notes. External data might include research studies or even fitness tracker data from wearables like smartwatches. Together, they paint a more complete picture. But here is a warning: the famous phrase, garbage in, garbage out, applies here. If the data you collect is poor in quality, inaccurate, incomplete, or irrelevant, then no matter how advanced your analysis is, the results will be misleading. Data cleaning and preparation. Now, this is where reality sets in. Raw data is never perfect. It is messy. It has missing values, duplicates, spelling mistakes, inconsistent formats. If you ignore this step, you risk drawing the wrong conclusions. Cleaning means identifying and fixing these inconsistencies. Tasks include removing duplicate entries, filling in missing values where possible, then standardizing formats like dates and currency. And here is the truth, analysts often say that 80% of their time is spent cleaning and preparing data, and only 20% on the actual analysis. That shows you just how critical this step is. Data exploration and analysis. Once the data is ready, the fun begins. Now we analyze. Exploration means looking for patterns, relationships, and trends. It can be done through descriptive statistics like averages and medians, visualizations like bar charts or heat maps, advanced methods such as regression analysis, clustering, or even machine learning models. Let's take an example from Netflix. The company does not just look at total views, they explore when people watch, what they watch, and even how often they stop halfway through a show. That data is analyzed to recommend the next movie you should watch. Now imagine you had access to your own phone usage data. What would you discover? Perhaps that you use social media more at night or that your screen time spikes on weekends. That's analytics in action. But remember this, numbers alone don't tell a story, humans must interpret them. Interpretation means answering the so what question. For instance, imagine sales data shows ice cream sales peak in July. The raw numbers is interesting, but the insight is that hard weather drives demand. So the company should stock more before summer arrives. A good way to think of this stage is like a doctor reading a blood test report. The numbers are meaningless unless the doctor interprets them to diagnose the patient's condition. Communication and visualization. Now, insights are useless unless you can communicate them effectively. This is where charts, graphs, dashboards, and reports come in. The goal is to tell a story with the data. For example, rather than saying sales rose 15%, you would say because of Ramadan promotions, customer footfall increased by 20%, leading to a 15% rise in sales. That's a story, not just a number. Visualization helps because humans process images faster than text. A single graph can sometimes communicate what 10 pages of numbers cannot. Decision making and action. The ultimate goal of analytics is action. If insights don't lead to decisions, the entire process is wasted. For instance, after analyzing customer data, a bank might decide to introduce a new mobile loan product because they discovered that younger customers prefer instant credit. Insight without action is like having a map and never leaving your house. Finally, once a decision is made and action is taken, we must evaluate the results. Did the new product succeed? These lessons feed into the next cycle. That's why we call it a cycle. It never ends. You learn, you improve, you repeat. A company might launch a marketing campaign, analyze customer response, and then adjust their strategy in the next cycle. Think of it as a wheel. Each stage is a spoke, and together they keep the wheel turning. If one spoke is weak, the wheel is unstable. As you move forward in your studies and careers, always remember data is only valuable when it is part of a cycle that never really ends. Now we will zoom in on a very important idea, the stages of data analytics. The step by step journey from defining a problem to collecting, preparing, analyzing, and then using data for decision making. Now, I want you to pause for a moment and imagine you are a doctor. When a patient walks in, you can take different approaches. Like you can describe their condition and you can diagnose the cause, you can predict what might happen next, and you can prescribe the treatment. Data analytics works in exactly the same way. Organizations use four main stages of analytics, and these are descriptive analytics, diagnostic analytics, predictive analytics, and prescriptive analytics. We will explore each one with examples and practical uses. Let's start with descriptive analytics. This stage answers the question, what happened? It looks at historical data to summarize events. It does not explain why, it simply describes facts. Like a company reports that its sales increased by 10% last quarter. Similarly, a hospital notes that 200 patients visited the emergency department last week, and also a teacher reviews that the average student score in an exam was 72%. Notice all of this describes the past. Think of descriptive analytics as a rear view mirror in a car. It shows you what has already passed, but not why or what is coming next. Now we move to diagnostic analytics. This stage answers the question, why did it happen? It digs deeper into the data to identify causes, patterns, and relationships. For example, sales dropped last month. Was it due to reduced advertising or poor weather or competitor discounts? Similarly, patients visited increased. Was it due to the seasonal flu or a local outbreak? Imagine being a detective investigating a crime scene. Descriptive analytics tells you there was a crime, while diagnostic analytics helps you uncover the suspect and motive. Why do you think organizations often stop at descriptive analytics and forget to ask why? It's because diagnostic analysis requires more effort, but it's where the real learning happens. The third stage is predictive analytics. Here, the question is what is likely to happen in the future. This is where things get exciting. Predictive analytics uses historical data plus statistical models or algorithms and machine learning to forecast outcomes. For example, an e-commerce company predicts which products customers are most likely to buy next. A bank forecasts the probability that a borrower might default on a loan. Similarly, a hospital predicts which patients are at high risk of readmission. Think of weather forecasts. Meteorologists collect past and present data on temperature, humidity, and wind patterns, then use models to predict tomorrow's weather. Imagine if a university could predict which students are at risk of dropping out, what actions could they take to help those students early? Finally, we arrive at prescriptive analytics. This stage answers the question, what should we do? It does not just predict it, it provides recommendations and possible actions. It is the most advanced stage of analytics. A delivery company uses route optimization to recommend the fastest path for drivers. Similarly, Netflix not only predicts what show you will like but also recommends what to watch next. If predictive analytics says traffic is heavy on your usual route, prescriptive analytics says take this alternate road and save 15 minutes. So, to sum up, each stage builds upon the other. You cannot jump to prescriptive analytics without first understanding what happened and why. So, remember this, data analytics stages give organizations a roadmap for smarter decision making. Descriptive tells the story of the past, diagnostic explains the reasons behind it, and predictive gives a glimpse of the future, and prescriptive shows the way forward. So far, we have explored the data analytics cycle and the stages of data analytics. We now know how data moves through a structured process and how different stages help us describe, diagnose, predict, and prescribe. But you may still be wondering, Where exactly is data analytics being used in the real world? Well, the answer is everywhere. From the food you eat to the shows you watch to the medicine you take, data analytics is quietly working behind the scenes. Now, we are going to explore applications of data analytics across different industries. I'll take you through examples from business, healthcare, education, government, sports, and even daily life. By the end, you will just see how powerful and universal analytics has become. Let's begin with the business because that's where analytics is most visible. Companies collect mountains of data like customer purchases, website clicks, product returns, royalty card scans. But raw data alone is useless. Analytics transforms it into business intelligence. Customer segmentation is identifying groups of customers with similar preferences. For example, Amazon suggesting products based on your browsing and purchase history. Sales forecasting is predicting demand for the upcoming season. Retailers increase stock for winter jackets when data shows colder temperatures are coming. Marketing optimization, where companies track the effectiveness of advertisements, which one drove actual sales. Have you noticed how when you browse a product online, ads for that product start appearing everywhere you go? That's targeted advertising powered by analytics. Now, let's move to healthcare, a sector where analytics can save lives. Disease prediction, where using patient history and genetic data to predict who is at risk of diabetes or heart disease. Treatment personalization, where recommending specific therapies based on individual patient profiles. And operational efficiency is like hospitals analyze bed occupancy rates, staff schedules, and supply usage to run more smoothly. During the COVID-19 pandemic, data analytics help track infection rates and predict outbreak hotspots and allocate vaccine to high risk areas. Think healthcare analytics as a doctor with supervision, like able to not only see what's happening but also participate what might happen next. Education is another field being transformed by data analytics. Learning analytics is like tracking how students engage with online platforms, how many minutes they spend, which topics they struggle with. Performance prediction is where identifying students at risk of failing or dropping out, so teachers can intervene early. Curriculum improvement is schools analyze test results to see which topics most students find difficult and then adjust teaching methods. Many universities now use data analytics in online learning systems. If a student has not logged in for weeks, the system alerts instructors to provide extra support. This creates a more personalized education for each learner. Government also rely heavily on analytics for planning and decision making. For public safety, police departments use crime data to predict hotspots and allocate patrols. And policy making is like where government analyze census data to plan schools, hospitals, and transportation systems. And also, fraud detection is where analytics identifies unusual financial activity that might signal tax evasion or welfare fraud. Some cities use traffic data analytics to adjust signal timings in real time, reducing congestions. Analytics in government ensures resources are used effectively and citizens get better services. Now, application in sports and entertainment, like where coaches analyze player performance data to design training, and teams use analytics to prevent injuries by tracking fatigue levels. Also, recruitment decisions are guided by player statistics. In entertainment, Netflix and Spotify use analytics to recommend movies and music tailored to your taste. Similarly, film studios analyze box office trends to decide which movies to fund. Analytics makes your leisure time more personalized and enjoyable. Finally, let's bring it closer to home, everyday life, where applications in daily life like navigation apps such as Google Maps analyze traffic data to suggest a faster route. And similarly, e-commerce platforms like Daraz or Amazon recommend products based on browsing history. And also our fitness trackers like Fitbit analyze your steps, sleep and heart rate, giving health insights. And also social media platforms analyze your likes and comments to curate your feed. Even when you order food online, data analytics decide which restaurants appear at the top of your search results. It is so integrated into our lives that we often don't even realize it's happening. The big idea is this: data analytics is everywhere. It is shaping decisions, improving efficiency, and even saving lives. Every time you see a recommendation, a forecast, or a decision, remember there is data and analytics working silently behind it. Now we will talk about the implications of data analytics. By now, it should be clear that data analytics is powerful. It improves decisions, saves resources, and personalizes experiences. But like all powerful tools, analytics also has consequences. And here is the thing: these implications are both positive and negative. On one hand, analytics can bring innovation, efficiency, and growth. On the other hand, it raises issues of privacy, bias, ethics, and even changes the way jobs and societies function. So, in this topic, we will carefully walk through the benefits and opportunities as well as the challenges and risk of data analytics. Let's start with the positives because they show us why analytics has become such an important part of our world. Number one is better decision making. Analytics transforms raw numbers into actionable insights, and businesses can decide which products to launch, hospitals can predict patient needs, governments can plan infrastructure. And number two is efficiency and cost savings, where analytics helps organizations identify waste, optimize the processes, and reduce cost, like delivery companies optimizing routes to save fuel and time. And number three is innovation and new services, where analytics enables the creation of completely new services like Netflix recommending shows, fitness apps giving personalized health advice. And number four is personalization, where customers get personalized shopping, entertainment, and learning experiences. For example, e-commerce suggesting products you are most likely to buy. And number five is social benefits. Governments use analytics for crime prevention, disaster management, and public health monitoring. For example, tracking the spread of COVID-19 helped save lives globally. Which of these positive impacts have you personally experienced in your daily life? Think about your apps, your shopping, your studies. Can you see analytics working behind the scenes? Now, let's turn to the challenges because these are just as important to understand. Number one is privacy concerns. Yes, data analytics often involves personal information like browsing history, location, health records, and misuse or leaks of this data can seriously harm individuals. For example, social media platforms tracking users across apps and websites. And number two is security risk. The more data we collect, the bigger the target for hackers. A single data breach can expose millions of customer records. For example, credit card breaches at major retailers. Number three is bias and discrimination. If data is biased, the analytics will also be biased. This can lead to unfair treatment, especially in hiring, lending, or law enforcement. For example, an AI system trained on biased data may reject loan applications from certain groups unfairly. Number four is ethical concerns. Just because data can be analyzed doesn't mean it should be. Question arise, should employers monitor every move of their staff? Should companies sell customer data? Ethical guidelines are often unclear or ignored. Number 5 is over reliance on data. Organizations may trust numbers blindly, ignoring human judgment. For example, a predictive model says a student will fail, but what if the student improves dramatically after mentoring? And number 6 is job displacement. Automation and AI powered by analytics can replace human workers, like chatbots replacing customer service agents or self checkout replacing cashiers. While new jobs will emerge, many traditional roles may disappear. And number 7 is legal and compliance issues. Laws like GDPR in Europe require strict handling of personal data. Organizations that fail to comply face heavy fine. Do you think companies should have the right to sell your personal data? If you agree to terms and conditions without fully reading them, this is one of the most debated ethical questions today. Finding the balance. So, where does this leave us? Analytics is not going away. In fact, it will become even more central to our lives. The challenge is to balance opportunities with responsibilities. Organizations must ensure data privacy and security. Analytics must watch out for bias and fairness. Governments must create laws and regulations that protect citizens. And individuals like us must stay aware of how our data is being used. Think of analytics as electricity. It can power a hospital or it can cause a fire. The difference lies in how responsibly it is used. The key lesson is this: data analytics is a double edged sword. Used wisely, it can transform society for the better. If used carelessly, it can cause harm. As future professionals, you will not only use analytics but also shape how it is applied. The responsibility to use data ethically, fairly, and responsibly rests on all of us. As we come to the end of this lecture on Chapter 3, Introduction to Data Analytics, let's take a moment to reflect on what we have learned. We started by walking through the data analytics cycle, like the continuous loop of defining problems, collecting and preparing data, analyzing it, interpreting insights, and making better decisions. Then we explored the stages of data analytics from describing past events to prescribing future actions. We also saw the applications of data analytics across business, healthcare, education, government, sports, and our daily lives, proving that data is everywhere around us. Now, finally, we consider the implications of data analytics, like the benefits it brings, efficiency and innovation, but also the risks such as privacy, security, and ethics. The key takeaway from this chapter is simple: data analytics is both powerful and impactful. It can transform organizations and societies, but it must be used responsibly. Thank you for joining me in this session. In the upcoming chapters, we will continue building on these ideas, exploring more advanced concepts, and connecting them to the practical applications. Until then, keep observing the role of data in your everyday life. You will be surprised at how often analytics is working silently in the background. See you in the next class.